So welcome to my presentation of 51 Pegasi b, the first discovered exoplanet. Figure 1. Before I get into introducing it, just wanted to show a very cool artist render of the planet that I found. Okay, so let's talk about the fascinating exoplanet 51 Pegasi b. It was dubbed by astronomer Geoffrey Marcy as Bellerophon. 51 Pegasi b was discovered in 1995. Marcy was one of the astronomers who helped confirm its existence. Named after Bellerophon, a figure from Greek mythology who rode the winged horse Pegasus. It became the first confirmed planet found orbiting a sun-like star. This discovery marked a breakthrough in astronomy and laid the groundwork for the techniques we use to detect exoplanets today. Scientific facts. 51 Pegasi b is a gas giant exoplanet that orbits a G-type star. Its radius is estimated to be 1.27 times the radius of Jupiter, and it's about 47% the mass of Jupiter. And here's a quick image that kind of shows the scale of 51 Pegasi b compared to Jupiter. Temperature. 51 Pegasi b orbits its star at only 0.05 AU. This is approximately 1/20th the distance from our Earth to the Sun. So in other words, it's extremely hot there. And here's a little image that kind of shows how hot it would be. "51 Pegasi b is a gas giant like Jupiter and Saturn. Its atmosphere is said to be mostly composed of hydrogen and helium. It lies about 50 light years from Earth in the constellation of Pegasus, hence why it's called Pegasi b. And here's another figure. This is kind of gives you a good idea of the scale of the planet and just how small we are compared to it, and the size of Jupiter compared to it. So yeah, it's a massive planet. So I want to talk about the prospects of it containing water. Astronomers found water vapor in the atmosphere of 51 Pegasi b using a brand new technique. Until now, we've only been able to spot water on other planets when they pass directly in front of their star as seen from Earth. This is also known as the transit method. Birkby and her team used the very large telescope in Chile to observe 51 Pegasi b along with its host star. Normally it's hard to separate the light coming from the planet and the star, but they found a way to do it. As the planet moved away and then back towards Earth, its light shifted to redder and then bluer wavelengths because of the Doppler effect. By analyzing this light, the team could separate the planet's atmosphere from that of its star and Earth, and they were able to detect signatures of water. Discovery. 51 Pegasi b was discovered in 1995 by Swiss astronomers Michael Mayer and Didier Queloz using the Elodie spectrograph at the Haute Provence Observatory in France. Elodie separated the star's light into a detailed spectrum, allowing them to track tiny rhythmic shifts in 51 Pegasi's stellar barcode. These shifts caused by the radial velocity wobble of the star revealed that an unseen massive planet was tugging on it every 4.23 days. After ruling out other explanations, they confirmed it was a close orbiting gas giant, marking the first exoplanet ever discovered around a sun-like star, and launching the modern era of exoplanet science. And here's a little figure here that gives a brief explanation on how radial velocity works in discovering exoplanets. Habitability. 51 Pegasi b is a hot Jupiter, a gas giant that orbits extremely close to its star. Its estimated temperature of around 1010 Celsius makes it far too hot for life as we know it. Being a gas giant, there's no solid surface. There's only layers of dense hydrogen and helium, which would make it impossible for life as we know to establish a stable environment. The planet's intense stellar radiation and extreme atmospheric pressures would further prevent the presence of liquid water or any stable environment suitable for life. So in summary, in my opinion, I don't believe 51 Pegasi b is a habitable planet, nor does it have the conditions necessary for life to develop. And here's another artist figure that I found on the internet that I thought was pretty cool. And to wrap up, 51 Pegasi b was a groundbreaking discovery as the first exoplanet found around a sun-like star. Even though it's too hot and gaseous to support life, studying it has taught us a lot about exoplanets and their atmospheres. New techniques like separating a planet's light from its star through spectroscopy, new technologies like the Very Large Telescope, can now separate a planet's light from its star, helping us learn more than ever about these distant worlds. And in the process, we're reminded just how small we are, just how little we know. And here's my final figure. And it's just meant to depict how small we are. We're just like a speck of dust in the scale of the universe. And that is it for my presentation. I hope you enjoyed.